In section 4, we will learn about how to use recurrent neural network to forecast the stock market. Introduction to recurrent neural networks. So in the previous section, we learned about convolutional neural networks and we designed a convolutional neural network to actually classify traffic signs. But one question that I have in my mind is that what if the input and the output are of variable length? So can we use a convolutional neural network in such case? Well, the answer is no. Another very important question is what if I have to remember some sequence? Say, as you are listening to this video, you understand each word based on your understanding of the previous words. So you don't have to start thinking from scratch again. If I have to model such thing, then are convolutional neural networks enough? Well, the answer is no. That is why we have another type of neural networks called recurrent neural networks. RNNs have a variety of applications in time series modeling or speech recognition tasks or maybe natural language processing. You can think of one example like Amazon Alexa. So whenever you say something to Amazon Alexa, it actually recognizes the context of your question and answers accordingly. So this is one thing that can be done using RNN, understanding the context of the question or the situation and then responding to it. So we have already talked about some limitations of convolutional neural networks, but why do we need recurrent neural networks? So it turns out that not all problems can have a fixed length input and output. So problems such as speech recognition or time series require a system to store the state and use the context information to actually perform a certain task. What actually happens is that a standard neural network does not share features learned across different positions of text because in traditional neural network we assume that all inputs are independent of each other. Like in the previous section, we actually modeled traffic signs, but the sequence in which the traffic signs occurred did not matter to the network. But in case of RNN, the sequence matters. So suppose if you want to predict the next word in this sentence, you need to know which word came before it. So RNN takes the previous output as the input and then it can have some memory that saves the previous results. So two things are very important. First is that RNN is a network which has memory. Second, RNN takes the previous output as input to the current state. So these networks are called recurrent because they perform the same task for every element of the sequence. So in the diagram we can see that the current cell takes the current input and the output from the previous unit and performs some task. So RNN is basically a collection of such cells that perform these tasks. So there are various number of RNNs, one-to-one, one-to-many, many-to-one, and many-to-many, and many-to-many. So RNN have various variations. So this diagram is being taken from a blog post from Andrej Karpathy. It's a very good blog post. You must read it for RNN. So prime example of one-to-many is music generation. Actually, you define the genre of the music and in the output what you get is the music. Then we have many-to-one in which you have a long sentence and finally you actually classify the sentence based on some context of the sentence. So it is useful for sentiment classification of user reviews on popular websites like Amazon or Yelp or Yahoo. And then we have many-to-many translation in which we can have either the sequence length of the input equal to the output, and if in case the input length is not equal to the output length, then we call it machine translation. You can think of example like from English to Hindi, and if the input sequence length is equal to the output sequence length, then we are solving a problem called name entity recognition, in which actually the RNN tries to classify every word in the sentence whether it is the name of a person or not. So these were some of the RNNs. So this is all about the basics of how RNNs work. So there are just two things. The first is that it takes the previous output as the current input and it has a memory that stores the state of the previous outputs.